Hi, my name is Stuart Lynch, and in this video I want to show you how we can use alignment guides in SwiftUI to align views differently in your UI. And we'll start with the basics of an alignment guide for the VStack, the HStack, and the ZStack containers. And then next we'll discover how we can adjust subviews of that container stack where we can set or transform the alignment in the direction of the container's alignment guide, either towards it or away from it. Then we'll follow that by looking at how we can adjust subviews positions even further using the Alignment Guides ViewDimensions struct, and that'll provide us with both the dimensions of the view, but also access to the actual alignment guide, and that's through its subscript. And then we'll finish off by showing you how you can create your own custom alignment guides so you can align views in one container with views or alignment guides of other container views. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. Alignment guides in SwiftUI are a powerful tool for precisely aligning views within a container. We use these all the time in our applications in VStacks, HStacks, but probably less frequently in a ZStack or a ZStack. An alignment guide, when set at the container level, will align all sub or child views to that guide. I have a starter app for this video, and I'll leave a link in the description. And I recommend that you download the project and work along with me, because in the end you'll have a set of examples that progressively introduce you to new concepts that you can refer back to in the future should you need a refresher. I'm constantly looking back at my sample projects. So let's get started with the basics. In this example, I have a VStack with three views: an HStack, a divider view, and a text view. Alignment guides get applied to views within a container view. So in order to see how we can affect these views here, let's apply a border to the VStack and the HStack. I'll start with a red border on the VStack, and then I'll apply a green one to the HStack. Now, none of this should be new to you, but it's worth understanding the concept of alignment guides before we dig deeper. It looks like my red VStack has views that are centered horizontally within it. The divider view is one of those views that takes up as much space horizontally that's provided, so that's why it's expanded to the edges. But the HStack and the text views are views that only take up as much space as they need, and you can see that they are centered horizontally in that VStack. The alignment guide for a VStack will align all sub or child views to that guide. But where is it specified that we use center? And can it be changed? Well, if we option click on the VStack and then open in the developer documentation, we can scroll down and see the initializer for the VStack. So let's drill down on it too. And it's here that you see the alignment is a horizontal alignment type, and it's set to center by default. Now there's a spacing argument that's nil, and the content is a view builder that the views within the container all display. Well, drill down on the horizontal alignment, and you'll see that it's a struct, and that struct has three static properties that we can use: a leading, center, or trailing. So if we return to Xcode then, we'll see that if we add an alignment argument to our VStack and set it equal to a center, nothing changes. If we change that to either a leading or a trailing, however, we see the effect that it has on all of the subviews. They get aligned with either the leading or trailing edge. So for clarity, let's just set it back to center. And I know this is redundant as that's the default, but I'm just going to leave it here. So let's check the initializer for an HStack by drilling down here too. This time the argument for the alignment is a vertical alignment type, and it too is set at center. But this is a different center. This is a vertical center of an HStack and not the horizontal center of a VStack. If we drill down on the vertical alignment, I see that we now have 5 static properties to choose from: top, center, bottom, first text baseline, and last text baseline. Back in Xcode, we see that indeed the 2 text views inside our green HStack are centered vertically, and we can verify that by setting the alignment to center and see that nothing changes. if we change the alignment to bottom, we see that the text aligned to the bottom edge of our stack. Now you'll notice that the P and the G in this text goes below the baseline. So that's why when we set our alignment to bottom, it appears that the sleep tight is lower than the hello world. Hello world has no descendants, but if we change the D to a Y, you can see that it reaches the bottom. Let's change it back to a D. Now, if we want to change it so that our text aligned by the baseline, we have two choices that we can align by, and that's either the text line of the first view or of the last view. In both cases here, we get the same effect. Now, I'm going to get into how you can get much more control over the alignment of these views in just a minute. But first, let's take a look at the alignment guides of a Z or Z stack. In this example, I have a number of Z stacks all within a V stack so that we can work on different examples of basically the same content, just different frames. As you'd expect from our experience with a V stack and an H stack, the alignment of all of our views in the Z stack have a default alignment, which is center. We can confirm this by, again, option clicking and drilling down to find the initializer that confirms that. You can't see it on the screen here, but I'm clicking on the Open in Developer Documentation link. We can also see that this is neither a vertical nor a horizontal alignment. It's a straight alignment type, and that's because it's composed of both the vertical and horizontal alignments, and center, as you can see, is the middle of the container. We have a number of other static properties that we can see and use here. So let's return to Xcode and add an alignment property for the Z stack and test some of these out. And you can see that each time I change the alignment, the blue view lines up that edge to the corresponding edge of the red view, so top to top, or top leading to top leading, and so on as we work through each of the different types of alignments that a Z stack offers. As I mentioned, center is the default, but I want to align this Z stack to the leading edge. And I want to adjust this blue view now that's at the leading edge so that I can either move it horizontally away from that edge in either direction. And in order to do this, I can apply an alignment guide method. Now this method has two overloads, as you can see, one for a vertical alignment and one for a horizontal alignment, because we're in a Z stack. Well, since we gave our chosen Z stack the leading alignment, we want to choose the horizontal alignment guide overload and specify that we're going to override the leading edge guide. The second argument is a computed value that is a closure that provides us with a ViewDimensions type that returns a CG float. So we can hit enter on this and provide a label for our ViewDimensions. Now we know that it should return a CG float, so let's just ignore that D right now and just return 50. What you see now is that the blue view's new alignment to the base Z stack is at 50 pixels in from its leading edge, so that only 25 pixels extend into our red view that has not been adjusted with an alignment guide. And because we don't use this D, we can replace it with an underscore. Well, in the second Z stack, let's align it to the top this time. And that's a vertical alignment that we want to adjust. So since it's a vertical alignment, we'll need to specify the vertical alignment for our alignment guide. So let's apply that to the red rectangle this time. And for the computed value that's returned, let's ignore the dimension and let's just return -50. Since this time we're setting it for our red view, our base blue view has not been adjusted. So this moves the red rectangle down 50 so that its new top edge is 50 below the blue one, which is aligned to the top. Well, we know if we fail to specify an alignment guide for a Z stack, it's going to be assigned the center alignment. So in this example, if we want to adjust the blue stack so that its center is 75 points from the center of the red stack, what do? Well, we're going to have to be a little bit more clear here because a Z stack has both a horizontal and a vertical position. So when we move it from the center, we need to move it both horizontally and vertically. So let's set the alignment guide to center and set it to 75. But when we do this, we get an ambiguous use of center. So although we specified we wanted to use the horizontal guide, we still have to be specific here because both horizontal and vertical alignments have a center. Now, if you want the center moved 75 in both directions, we'll need to add another alignment guide modifier, but that time specify the vertical alignment center. Well, up until now, we've not used that dimensions variable at all. So in this example, let's start by applying an alignment to the ZStack to be aligned to the leading edge. And then I'm going to set the rectangle so that its leading alignment guide is moved 50 in the leading direction, but I'm going to keep the D label in here this time. Now, if I option click on that, I can drill down on the ViewDimensions struct. And if you scroll down here, you'll see that not only does the ViewDimensions offer us the ability to get the dimensions of a view, but also access to the actual alignment guide through a subscript using one of those guide static properties. So let's start with the dimensions. We have both width and height. So instead of returning a simple 50, we can use the dimensions width, which we know is 75, and move it half that distance. And so now we see that that blue rectangle's aligned with the leading edge halfway in. Okay, we've looked at how we can apply the alignment guide in a ZStack's views to align views differently in the horizontal and vertical directions. That alignment guide returns a float that simply aligns the applied view differently with respect to that parent's alignment guide. Well, we return a simple float, and we also use the view's dimension to alter the alignment's distance based on either the width or the height. In this section, I want to actually utilize the ViewDimensions guide by way of its subscript. The subscript is the view's vertical or horizontal alignment. So let me show you by way of this example. In this view, I have 3 images all aligned in an HStack, and we know the default alignment is center. Now, we really can't tell here because all of these views have the same height, but trust me, they're aligned to the center of this HStack. Now, to get a better idea what's happening, let's apply a red border around it. So what I'm going to do is I'm going to change it to a bottom vertical alignment for that HStack. Of course, again, nothing changes because all 3 images are the same height and their bottoms are all aligned evenly. So it looks just as if we had a center alignment. What if, however, we leave that first one alone, but to the second view we apply an alignment guide and get access to the view dimensions? Remember, not only does it give us access to the width and height, but also the vertical alignment guides that are possible. Well, the reference is the HStack's bottom vertical alignment. So if we can align this using the bottom alignment of an HStack using its bottom alignment, nothing changes. We're simply saying align the bottom with the existing bottom. Well, that doesn't make much sense. But vertical alignments have a number of other options for us, one of which is center. So let's change this to center and look what happens. Because the center alignment is accessible for both the vertical and horizontal alignments, we have to leave that vertical alignment in. So what you're saying now is instead of using the second view's bottom for the alignment, use its center and align that center to the bottom, which is the default, which is the same one that we've used for the first one. So right now, 1 and 3 are both using the normal bottom alignment. So they're lining up. So let's add an alignment guide to the third view, which again references the bottom alignment of the original stack, which is the same as the bottom for the view. But let's access its top subscript. The top of the view 3 now is aligned with the bottom of the first one, which is the original bottom. If we draw a horizontal line at the bottom of view 1, we see that it runs right through the center of view 2 and the top of view 3. And because there's no ambiguity here for this, where we have a vertical or horizontal alignment, since top is only a vertical alignment, we can remove the vertical alignment struct's name. We only need to specify that if it's center. In the second example, I have 3 text views representing the formula for water. I want to tighten up the spacing and set the alignment to bottom. So let's change that right now. Alignment of bottom with a spacing of 0. And then I want to change the font size of this text view displaying the 2 to be a title 2. Well, this actually looks like it's dropped, but this is really because the descenders for large title are larger than for title 2. And this may be good enough for you, but we're here to discuss alignment guides, and I want this bottom to be even lower with reference to the original's bottom guide. So we'll use the alignment guide, referencing the bottom, that's the default, and then access the dimensions bottom for this view that we're changing, and subtract 5. Well, for this third example, I have this light bulb image, and it's scaled to fit with a width of 30, and the text view displays the string energy, and it's all in an HStack. So what I want to do is to change the alignment of this light bulb so that its bottom edge is aligned to the center, and the text so that the baseline is aligned to the center as well. So I'll apply an alignment guide with reference to the HStack's vertical alignment, which is center, but again, avoid ambiguity, we'll need to specify the vertical alignment center. And then you see that the bottom of the light bulb now moves up to be in line with the center of the energy, which is still at the default center alignment. Now, if we want to move the energy text view to match the baseline with the center of the HStack, we can do exactly the same kind of thing, where we'll specify the alignment guide is the vertical alignment center, but we'll take the dimensions first baseline to align to it. Well, there's one more thing that we need to cover, and that's a custom alignment guide. Well, up until this point, we've been applying alignments to views based on the parent container's alignment guide. So let's consider this example. I have a VStack with 3 HStacks embedded within it. Well, what I want to do is to align all of the trailing edges of the first views in each HStack with the vertical center point of our VStack, so that all the second views then will be right adjacent to them, so it'll look like a 2-column display. You see what's different here? My alignment guide for my HStack is going to be my VStack, not my HStack itself. You may be telling yourself, well, I don't need to do this. I could simply use the new grid view to accomplish this. And you'd be correct. And indeed, it would be better. But doing it this way will give you a good example of how to create and use custom alignment guides if you need them. So in order to accomplish this, we'll need to create what is called a custom alignment. So the first thing we'll need to do is to create an extension for whatever alignment guide we're trying to use. So in our case, it's the horizontal alignment guide for our VStack. And then within the extension, we create a struct or an enum. I prefer an enum that conforms to the alignment ID protocol. And I suggest that we use an enum because we'll never be instantiating multiple instances of this object. So I'm going to call it 2-column alignment. Now we're conforming to a protocol that has a required method. So I'm going to let Xcode fix that for me. Well, the default value function accepts a context, which is a ViewDimensions object, and returns a CG float. This is very familiar. So what we can do is use the subscript to reference the alignment guide value for the object we are applying this to. And since it's going to be for the VStack, we'll need to access the horizontal alignment guide, and we'll want the center one. Now, like we do for our custom view properties and preference keys, we can make this call to this static function much easier by creating a custom property that is of type horizontal alignment, and return the horizontal alignment, which requires an alignment ID, which is our 2-column alignment, and we'll need to specify self to represent that object type. Well, now we can put this to use. If we apply the custom 2-column alignment to our parent VStack, we're establishing the position at the center to be the new alignment guide. So then for each of our first items in our HStack, we'll want to align the trailing edges to this vertical line. So we can do that with an alignment guide. We specify that our alignment guide for our view then is aligned to that custom one. And then when we get our view dimensions, we can use the trailing subscript to specify that the first view in our HStack's trailing edge lines up with the center alignment of that VStack. And then we can repeat that same alignment for each of our other 2 HStack's first views. And there you have it. Now there are lots of detailed blogs about alignment guides because it's not exactly an easy concept to get through your head. Hopefully I've tried to shed some light on that, but I'll leave links in the description if you prefer to read. I hope this video has provided you with some insights and understanding of how alignment guides work, and have given you some food for thought if you want to do some custom alignments of your views in SwiftUI. And you may find that you can use alignment guides without having to access or use the geometry reader to get the positioning that you want. If you've enjoyed this video, please give it a thumbs up and leave a comment, as that will drive more people to my channel. And be sure to subscribe to the channel to get notified when new views are available. Thanks for watching.